Right, welcome. Let's have a look at alkanes and some of their physical properties. And would be, what is the difference between alkanes and alkenes? Well, you would remember that alkanes only have single bonds and alkenes double bonds. We talk about alkanes as saturated and alkenes as unsaturated. Um, Also, with the difference, you would remember that alkenes react almost instantaneously with bromine water, decolorizing it from the brown to colorless. Right? This is because my double bond react, it breaks and it bonds to my bromine atoms. Uh, while in alkanes that are unreactive, bromine water will remain brown because the test also that you need to remember. They ask it. Just remember with fractional distillation, I'm not going to go into crude oil and the different fractions and the fuels and all of that. Please, this is theory that you need to know. You need to know what is fractional distillation. You need to know what are good characteristics of a good fuel. What are the characteristics of a good fuel? So that's summarized, right? Physical property of alkanes and alkenes in here. Remember, this is almost, it's not something for you to study, it is something to logically think about. As my chain length increases, my intermolecular forces would increase. We're dealing with van der Waals forces, right? So that means greater size, more electrons present in my molecule, the stronger my van der Waals forces would get. So up until about 4 carbons would be gases, 5 to 17 liquids, and 18 solids. And just a note also that my alkanes are less dense than water, so they will always float. Remember that like dissolves in like, so alkanes are non-polar, water is polar. We're not going to get that. You will need a non-polar solvent to dissolve an alkane. Melting and boiling points, as mentioned, uh, and there's only van der Waals forces present in pure alkanes. So with longer chains, there is a greater surface area, greater molecule size. Right, so then we need more energy to break it. Interestingly enough, my branch chains have a lower boiling and melting point. The reason for this is that they have a more spherical form. So there's a smaller surface area, less electrons for attachment points, therefore also weaker forces. Have a look at this. My, my hexane there is one straight chain, while if you have your 3-methylpentane, it's a slightly more condensed structure. And the more side chains you put in, the more spherical my molecule gets. And although you have the same amount of electrons in there, the surface area is less for attachment points. Therefore, my boiling points decrease. Look at the significant decrease that we have in there. Okay, let's raising that. So, just interesting for the melting points as well, slightly different with the even and uneven numbers. And the reason for my odd numbers having a slightly lower melting point is just again about the structure. So it doesn't pack as well, so you need slightly less energy to break it. So although there's an increase, there's not a continuous trend of that. A few terminologies that we need to talk about: volatility and vapor pressure. What is volatility, or what is a substance that is volatile? Well, it's a substance that can easily evaporate, go from liquid to vapor. That vapor causes a pressure, and we refer to that as vapor pressure. We'll look at that when we look at the chapter and topic on equilibrium. Weak intermolecular forces between molecules would cause a substance to vaporize easily. I think that is now common knowledge to most of you already. So when a substance has a high vapor pressure, there would be weak intermolecular forces within the substance. Just talking about halogenoalkanes, they vaporize very readily, and that's why they've been used in aerosol sprays. Right? Don't talk about the chlorofluorocarbons that destroy the ozone, but yes, those are in there. So that's why there would be quite significant advances. Another term is viscosity. Viscosity refers to the degree of fluidity. Something is low in viscosity, it is runny. A high viscosity substance would be something like honey. Right? As the length of chains increase, again, intermolecular forces become stronger because there's more electrons, there's greater molecular size, greater surface area, and the liquids become more viscous. This is a table just from one of the textbooks, just showing you, yes, there is a trend in boiling point, there is a trend in melting point and in density. Not to study, just to know. Alright, let's start with our reactions. We all know that our hydrocarbons are good fuels. They burn and release a lot of energy, so they are highly exothermic. Okay, bad thing, yes, carbon dioxide is also produced in there. So you must know that when an alkane reacts with oxygen, carbon dioxide and water is produced. So this would be a 2-mark question to write a balanced reaction. Writing it by stating the products will give you 1 mark, and balancing it will be the 2nd mark. Now, for alkenes and alcohols, exactly the same thing, but there's also a little formula and that you could remember for complete combustion. You can do it with inspection as well. But there it is. I wouldn't spend that much time on it, but for those of you who are looking for your A pluses, that's the one that you need to go for. Incomplete combustion, remember, that is if there's insufficient oxygen in the reaction. Then we will get carbon monoxide and water that is produced. Pollution from combustion, yes. Listen, in the last few pages of the chapter, they deal with the environment and the impact on environment and so forth. We have 2 chapters, a whole topic dedicated to nitrogen and sulfur, those 2. And where we would also deal with our catalytic converter. So we will deal with this specifically later on. You guys may obviously, and please do read through this. It is nothing unfamiliar. You would have heard it in geography and in biology previously as well. So please read through that, and it is knowledge that you must have. So reactions of alkanes, we're focusing on substitution, and specifically the mechanism of it. The mechanism is called free radical substitution of alkanes. So what is a free radical? A free radical is something that is produced with an unbound electron. So we're looking at our first step in this reaction mechanism called initiation step. This is where a nonpolar covalent bond between 2 halogen atoms are broken by homolytic fission. So if we have our chlorine and chlorine in there, and I'm going to try this, so there's my 1 chlorine, and there's my other chlorine in there. This bond is broken, and there's my arrowhead and arrowhead. It's only half and half an arrowhead because each chlorine receives one of the bonding electrons in there. Please note, this is not like a dot and cross structure or a Lewis structure. We only show the bonded electron that each atom gained. This is known as a chlorine free radical. Remember, this is also a stable molecule, so we need high energy, and the energy comes from UV light to break this bond. Our second step in free radical substitution is known as propagation step. This is where a free radical that we've produced in our initiation step attacks an unreactive alkane to produce a different free radical and something like hydrogen chloride. Right, so in a propagation step, we will always have a free radical and a stable molecule, producing a free radical and a stable molecule. Right? Now, for my follow-up propagation, remember propagation means continuous. It goes on and on and on. So we have another free radical reacting with a stable molecule, attacking it, producing a stable molecule and a free radical. So this will continue forever unless my termination step occurs. What is termination? Termination is when we stop the reaction. This is when we have two free radicals reacting. For instance, a chlorine free radical with a hydrocarbon free radical. Free radicals pair up and we get a stable molecule. No more free radicals in my product, cannot continue. There are three possible termination steps in there. With my CH3 free radical producing an ethane, you could also actually have the original chlorine free radical plus another chlorine free radical, and that produces my Cl2. So this is also a possible termination step. It's a ridiculous one, but yes, it's still in there. One needs to read the questions on this part of work really well, because they would ask you, please show, through using the free radical substitution mechanism, how methane and chlorine produces an ethane at the end. Okay, and then this last step would be your termination step in there. So be careful with the question. The last bit is just on cracking, so just reminding you, definition for cracking is the process of breaking up large hydrocarbon molecules into smaller, more useful bits. Cracking of hydrocarbons could either be just thermal decomposition, or we could add a catalyst in there. A catalyst like platinum is usually used. Okay, if a catalyst is used, we have a lower temperature pressure. Okay. My example for you guys there is something from the XE work again. Decane, meaning an alkane with 10 carbons, can be cracked to produce an octane and an ethene. So very important, if we crack long hydrocarbons, there's a combination of an alkane and an alkene that is always produced. Right. Okay, I hope this was useful. I'll see you for alkenes.